So, hi everyone, welcome to the Waves 102 session. I've got Fabio here. So Fabio, over to you.
Thank you. So today we'll be talking about Ansible, and more specifically, where the Ansible code you would run on your system, where it comes from. So we'll be talking about supply chain kind of situations. So the first aspect is going to be the automation supply chain. So the Ansible automation in this case, but also it can apply to other kind of automation as well. The second aspect will be about how to secure it, and then some conclusions that we'll be drawing out of this. But first of all, who am I? So I've been working in IT since 2004, mostly in consulting slash infrastructure kind of roles. And I've been using Ansible for more than 10 years at this point, and I've also written a bunch of books on it. And at the moment, I am a principal specialist solution architect at Red Hat. So some disclaimers about what we are going to discuss today. The first one is obviously this presentation only wants to be a primer, not a full course about security. Obviously, we only have 45 minutes or so now today, and that would not be even close to enough to have a whole conversation about security. The assumption is that this is just going to be a very high level conversation about these kind of issues. And you will have a lot of links about the various things to then go in deep in various aspects if you are interested in it. Second aspect is that everything we are going to discuss today is fully open source. So even though there is a commercial product that is called Red Hat Red Hat Ansible Automation Platform, the open source version of this product is also available, and everything we are going to discuss today works exactly the same on both the open source version and the commercial version. So you are set no matter which one of the two you are going to use in your real life. There are a lot of links at the end of the slides, and also the slides will be present on the website of the GSC so that you can then click around the links. So let's start from the very beginning. Supply chain attacks, what they are and why they are relevant to us. The definition, classical definition of supply chain attacks is that a supply chain attack refers to any kind of malicious activity that targets not really the development, the code itself, but the processes around the code. So it can be the sourcing of the code, potentially the development of the code, but by development in this case, it's not the person writing the code, but it's all the tooling around it, the distribution of the code and the deployment of the code. So the idea is basically not to attack the target itself, but to attack the long tail of operations that lead to the current state of the target. Because a lot of times, those are weaker links than the target state. So why should we care about supply chain attack as IT people? First of all, it can have devastating impact on organizations, because the reality is if you compromise something, a source code or some component that is way up in the supply chain, it will also be in one supply chain, but it will also be in many other supply chains, which means that the impact of that kind of attack, it will be massive. The second aspect is that it is very difficult to detect, and this is due to many different reasons. I think the biggest reason is that it's a new kind of attack. Historically speaking, we have seen supply chain attacks in the last few years, but back in the days, this was not a common way of doing attacks, so they are probably less understood in general, and we have less tooling compared to other kind of vector attacks. It can be very difficult to defend against them, This is partially due to the fact that we don't have the tooling, but also partially due to the fact that while the target is a very clear thing, very easy to identify. So let's say I have an Apache server somewhere, for instance, it's very easy to say that service and be like, is this service actually safe or not safe? Or should I do something to make it safer? I can write automation code to detect if it's vulnerable to some kind of attacks and so on. While if we're talking about supply chains are something very complex and they can be very, very long. And the more you think about supply chains, the longer you discover they are. So it's inherently also more difficult than other kind of attacks. Also, an aspect about a consequence about that aspect that I mentioned before, that you can attack the supply chain very far away, is that there is obviously the intended target that you are targeting. So, for instance, this can be I attack one single component and how it ends up in the company X architecture. But the reality is, if I attack that target, that component, that same component will end up in 1,000 different other companies' architectures, which means that there are a lot of non-intended targets that are still attacked in this way. And also nowadays, it's becoming more common, a more common way of attacking infrastructures. And there are a few reasons for this. One of these is that we, as a society, as IT professionals, have become fairly good at securing the target themselves, but we are still very immature in the whole securing the whole supply chain. So obviously, it's an easier target today than the frontal attack to an infrastructure. So why should we care about supply chain attacks? And by we, I mean people working in automation space or more generally having to handle automation code. Why automation code is special to any other kind of code? Because it is. First of all, Ansible code and more generally any kind of automation code tends to run at very elevated privilege. So often root or root level kind of account are used. And this is obvious because obviously we want to be able to use that code, the good code, not the malicious code, to actually do things that usually are only available to sysadmins. So obviously we will need to run this code at very high level with very privileged access, which means that if malicious code ends up in our pot of code, that code will also be executed with the same elevated privilege. Also, there is an aspect about Ansible, which a lot of Ansible code supply chains are not very secure. And I would argue that a lot of times, if I go to someone and ask them, what's your Ansible supply chain code supply chain, they have no idea about it. Or maybe they have an idea, but it is very wrong. So let's start from this last point and let's discuss about mapping it and how it usually evolves and why it becomes a problem from a certain point onward. At the beginning, it's not really a problem. So usually the way automation starts in general, but obviously we're talking about Ansible automation. So the way Ansible automation starts is something like this. You have a developer that runs Ansible on their local node. So really on their local machines, their laptop or whatever they are using, and manage some nodes. This can be known to their management or not. Hopefully, it's known to their management. But this situation does not really have any supply chain and any supply chain security, therefore, because, or better, there is a supply chain because there are questions about where did you took the Ansible binaries from and those kind of things. But the reality is the automation supply chain, so the automation code supply chain, is basically zero because the developer is writing the code on their laptop and running it on the laptop. So the reality is that we have basically a zero supply chain. Now, it could be possible to attack that arrow between the developer and the managed nodes, but that arrow is usually an SSH connection, which we can define as secure, even though obviously it's possible to break it potentially, and it can be not well configured, so it might have some issues there. But reasonably speaking, we can say an SSH connection is safe. But the reality is that what happens after a while is that that developer, the team grows, or the manager wants to have more people writing code. So what happens is that we have multiple people writing code, committing it, hopefully to Git, and then that same developer as before is downloading the latest Git version, running the code, and managing the nodes. So as you can see, the last part of the workflow is the same because that developer is managing nodes from their laptop. But the reality is now we do have a supply chain that starts with the developers on the left side and is about how does the code arrive to on that developer laptop, the blue guy there. And this potentially opens us to some supply chain attacks because obviously that Git server could be potentially vulnerable to some kind of attacks. It could be possible to modify a little bit some commits so that maybe a developer commits something and then what ends up into the Git server is something different. So there are some possibilities, but still the situation is not that bad. What happens usually though is that that blue guy there at a certain point need to go to holiday. So what happens is that we start to have maybe another person that is now enabled to run the code or authorized to run the code. So we now have the situation where we have a little bit more complexity there. It's not only about that single developer, now those are two different developers. Now, in those cases, still as for the previous cases, the supply chain security is less important because we still have a human there that is executing the code. Now, we can hope that that human is reading the code before executing it, is not blindly trusting their colleagues, because in the end is executing it with his account or her account. So obviously it's taking the responsibility of what he's executing. It's not a guarantee that that always happens, but you know that is something you would hope it happens. But the reality is this model is clunky. So what usually ends up happening is that those developers get replaced by a software, which is a controller. This can be either the Red Hat Ansible Automation Platform controller, also the commercial version, or AWX, which is the open source version of the Ansible Automation controller. It's exactly the same code base. The only difference is one is community driven, the other one is Red Hat driven and supported. But in this situation, we start to have an issue because now there is no check that what the developers actually are committing is, actually correct. So the situation, though, that often happens is that people comes to me and say, "This is our supply chain," and I always wonder, are you sure? Are you sure that your developers are actually writing 100% of the code they are committing or not? Because usually what happens is that they are actually using code that other people wrote. And usually those code are grouped in collections. Collections are a concept within Ansible, and basically it's an easy way to share and reuse code. And collections can be also shared online. So an example is galaxy.ansible.org, where basically is like a big repository of collections that are community driven, and everyone can upload their own collections. And one of the issues is that if your developers are using those collections without all the correct due diligence around them, the risk is that you are importing some code that someone else wrote, maybe someone in your company, or maybe someone external to your company, without any checks. So this usually is not a good situation. Now, the good thing though is that we have a well-known pattern to fix this issue, and it works by adding an automation hub. And automation hub, same thing as the controller. There is the open source version, community version, as well as the enterprise version. And then you can import those collections into the automation hub, and then they are used in the controller. The advantage of this is that you can then have policies and human checking that collections, and you have a clear track of what was approved by who. So in that way, you can simplify that system and ensure that only versions of those collections that have been vetted are actually usable within your architecture. Now, hopefully, you also have ACI, and if not, you can add easily ACI. Usually it's put it after Git. A lot of Git forges also have their own CI system. So GitHub has, for instance, GitHub Actions. There are GitLab pipelines and all the others. But the idea is that you can leverage those tools that come with your Git forge to already start to do some integration tests to check that your code is effectively correct. Now, in this case, though, you are not looking for fixing supply chain issues. You are simply looking for normal tests to ensure that the code that you wrote was the code that you wanted to write, basically, that you have not introduced any bug for whatever reason. Now, another thing that usually happens, and it's very good idea, is to also use execution environments. Execution environments are basically containers that contain both Ansible itself, the Ansible core, plus the libraries, the dependencies, potentially the collections that you are also using, and they are all together packaged in a single container. Now, the advantage of this approach is that you can then run certain playbooks on a specific version of that container. And if they run properly the first day, then they will always run exactly at the same way, because that container is going to be immutable, and therefore you will always have the same version of Ansible core, the same version of libraries, dependencies, and so on. Obviously, you can create new versions of those execution environments if you want to bump those versions, or maybe if you want to add more collections or libraries. But then also you're aware of that change, and then you can do the testing. Now, this also can help you a lot with the CI, because in the CI you can test all your playbook or Ansible code against the various versions of your execution environments, and then make decisions on which execution environment version to use in production and which not. So this is a very common way of structuring good pipeline, a good supply chain for your Ansible code. But the reality is that this workflow is not secure, because for every arrow you see here, there is potentially a supply chain attack that can happen, because supply chain attacks tend to attack in that link in between the steps. So what can we do to make this a more secure supply chain that can withstand attacks? So the first thing we can do is start from all those commits and get, we can make it more secure, just to start to ensure that whatever our developers meant to commit is exactly what has appeared in our systems. So we can use a lot of standard tooling for this. The first step is signing Git commits. So Git already has this feature embedded. You can use it with a capital S, and you can simply sign your commits. Basically, you are going to use an RSA or an elliptic curve key with asymmetric encryption to basically add a signature to it, so that basically you can check if it has not been tampered. So one thing is to sign it, and then also we will need to also validate it. Good thing here is that Git also has embedded the verify commit feature, which allow us to verify that a commit signature really matches with the commit content as well. So what we can do is ensure that our developer use Git signature features, and then we check them in the CI process. So in this way, what we can do is guarantee that whatever the developer had in their mind is exactly what it ends up in our CI. And this is very important because it guarantees us that no one tampered it in all those boxes. So we kind of create a trust box, from the developer to the CI included. Another thing we can do is to actually use Ansible project signatures to further this trust. This can be done with Ansible. Ansible has the Ansible sign binary. It's part of the Ansible core project. And what you can do is simply do a very similar process that we did for the commits at the project level. So we can sign it. There is also documentation, and also we can validate it. We can both manually validate it with Ansible sign, project GPG verify. So this is exactly the same as before, but we can also do it on AWX or Ansible Automation Controller UI, and there is documentation for that as well. And the reason why this is important is because it allows us to extend this validation to the controller. Now, as you can see, I have marked it in a way so that basically it means that it gets signed in the CI process and checked into the controller. The reason why I think this is a better approach than to have the developer directly signing it is that this also guarantees us that there is no possible way that the controller will execute some code that did not went through the CI, because the CI is the place where the signature get posted, and then the controller just ensures that every code that it runs, it has the proper signature that is posted in the CI process. So this also guarantees us, enforces us that model that we were describing before. We then have a point about the collections. Obviously, we have those collections coming in, but how can we be sure that they do not get tampered with? And the way to do it with Ansible collection signature, it can be done manually, which basically is a GPG again. I don't know if you have noticed it, but we have signed Git commits with GPG, though it was hidden in by the Git command. We have signed the projects, the Ansible projects with GPG, hidden by the Ansible project signature command. And here we are also using GPG again. We can use it directly, or we can also use it through Galaxy NG or a private automation hub, that automation hub box that we described before, either manually or automatically based on the approval policies. But in the end, it's still GPG working behind the scene to ensure that we have those signatures as soon as we receive the code that allow us to check at every single step that the code that we have is exactly the one that we had at the beginning. Now, it's also possible to automatically import signature from previous systems. So let's say that, for instance, your source for collections is not galaxy.ansible.com, but maybe it's a company such as Red Hat or maybe IBM or maybe some other company that provides you also the signatures for their code. You can also import those signatures to ensure that your supply chain security is stretches over your premises to the premise of your providers. And also we have documentation for those cases as well. We can then also validate collections, and collections can be validated, let's say manually via Ansible Galaxy with the command line tool. But also it can be done in Ansible Build, which is the tool to create execution environments, because as we mentioned, execution environments can contain collection, and it's very important to ensure that once that while we are putting collections into execution environments and baking them in, we are also checking that the source is correct and we have imported exactly what we were looking to import. But also it can be done automatically on AWS and Ansible Automation Controller to ensure that we are only executing collections that have been properly validated. So with those tools, we can secure all those steps. And more specifically, we can so have collections that are signed at the very early stage, and then we can check that the same collection is the one ending up in the automation hub, in the controller, and into the execution environments as well. Now, we do have those execution environments that have trusted collection in them, but how can we trust the fact that they are the execution, that we are executing the correct execution environment and not an untrusted one? And this is fairly straightforward because we said at the beginning that execution environments are containers. So containers have a lot of tooling about this. So we have Scopio, for instance. We can manually check sign with Scopio the container images, or we can do it with Podman that also have the same commands, same ability to actually sign the images. Also, we can do it either manually or automatically with the automation hub step. So effectively, in the processes of pushing, we can do the signing there as well, if that's better fitting for your supply chain and references as well. As for the validation, it's very easy because both Podman and Docker has this concept that is called container policy. The idea is basically that you can list a number of valid keys to sign containers images. And if a container image has not been signed by any of those valid keys, then it's not going to be executed. And it is very well documented as well. So with this, we can also add the other side, basically, of the execution environment's security, which is from the execution environment to the control. And as you can see, now we have a lot of those green boxes, which guarantees us that all those steps in between are secure from this perspective. And by secure, I just mean the fact that whatever happened to be the code or the artifact at the beginning of this box is exactly the same one as at the end of this box. So a few conclusions. First of all, the automation can be a very interesting target for supply chain attacks due to this fact that we tend to run with privilege access on our system. The second aspect is that automation supply chain tend to be very long and complex, which means that it's sometimes easy to forget about some parts of it. And hence it's very important to map properly your automation supply chain before doing any change, because if you do not know exactly what you are working with, it's going to be very hard to make anything, any change that is sensible. And also there are a lot of tools that can help you secure your supply chain. And the majority of those tools are not specific to Ansible or to one specific component of Ansible. But those are very standard tools. They have had a very long history so far, and which also demonstrate the fact that they are secure by themselves, and therefore they can help you a lot in your supply chain. With this, I thank you all, and please remember to provide feedback. Also, if there are questions, I think we still have a few minutes. We can have some questions if there are any.
Great, thanks, Fabio. Anyone got any questions? You want to put them in the chat? And there's also your feedback. So in the build your own agenda, you can click the link on the session and you can feed the feedback there, or you can go to the website using that URL on screen and put 2G. The feedback will be really useful. It'll help Fabio with his presentations and it'll help us with our selection. So, any questions? And much people deal with Ansible. I know it's not one that I deal with. Never touched it, so that was very insightful for me. No questions? Okay. I'll leave it there then. Thank you very much. Thanks, Fabio. Thank you very much for your for presenting, and to the audience, thank you for attending.
Thank you.
We'll see you in the next session. All the recordings will be available at some point in its coming weeks. Thank you very much.
Thank you, everyone. Cheers.
Cheers, thank you.